Welcome back, students. In this class we start a new chapter, real number, that is chapter 8. In this we solve the first exercise problem, that is use Euclid's division algorithm to find the HCF of. They have given 3 problems here. The first problem here, we'll start solving this. So first step is, so we have to use the algorithm to solve these problems, that is Euclid's algorithm. You may study this in the theory class. Okay, first problem. So first step, that is 135 and 225. Here we see that 225 is greater than 135. So let A is equal to 225 and B is equal to 135. So by next step is by using Euclid's algorithm. By using Euclid's division algorithm or division lemma. So next step, we can write this one as 225 is equal to, that is this one, take this number, this is the larger number first, take this number, that is 135 into 1, then plus 90. So 135 plus into 1 plus 90 will become 225. See here, 135 plus 90 will be 225. So this one is called dividend. And this one is called as divisor, into this one is quotient. And this one is called remainder, plus this one into this one equal, and this one is remainder. So here we took A as the greater number here. So I'll write A equal to greater number and B is equal to smaller number. So after this, understand this, we have distributed this one as dividend, this one as divisor, this is quotient, and this is remainder. Now we'll see the next step. We see remainder. What is remainder here? Here 90 is the remainder. So remainder 90 is not equal to 0. So what is the next step when this one is not equal to 0? We have to take this dividend. What is dividend? We have to take next step, that is, you can write here step 1 or you can write here as step 2. This 135 as the next dividend we have to take. Since this one is not 0, we'll take 135 as the divisor as the dividend. So as 135 here, so then new divisor will be, then in this step the divisor will be, that is 90. So we'll see this next one again. After this, again apply Euclid's algorithm. Now once we finished here, once we applied here, next this is the second time. Once we applied here, next here second time. So Euclid's algorithm. So what happens here, we'll see, or you can also say it is a lemma. Then what happens, this one will become dividend. Then which is the new divisor we got? This one, 90 into again 1 plus so much 45. So see, 90 plus 45 will be how much? 135. So in every step this will be changing until this, which one? This remainder is not equal to 0. So again what happens? Again in this step I will just write down this one step we finished here. Again this is another step. First we will write this one as step 1 once Euclid's algorithm applied. This one step 2. We will see this as step 3. Here in this case now we will take since we will see that is remainder is not equal to remainder. What is remainder here? That is 45, which is not equal to 0. Then what happens? Step 3, we have to take new dividend. Which is the dividend here? The dividend will be 90, and the divisor will be how much? That is 45. 45 we have to take. Again apply Euclid's algorithm. Euclid's division, or we can write algorithm also. So in this step 3 we'll see 90 is the dividend and divisor is how much? 45 into 2 will get how much? 90. So 45 into 2 will be 90 plus this one will become 0. So what happens? See, 90, this one 90 plus 0. So it's okay. Here how much? Remainder. Now what happens? Remainder is 0. Step 3 finished. Remainder is equal to 0. Therefore divisor here how much? Divisor is equal to 45. Therefore this one is the divisor. Finally we have to write hence the last step. Hence HCF, that is highest common factor of 135 and 225 is 45 is the answer. So how many times we applied the algorithm? That is Euclid's algorithm we applied 3 times. So until we get the remainder 0, we have to go on applying the algorithm. So this is the first problem. We move on to the second one in the exercise 8.1. So see, this one is 196 and 38,220. Here we have, just will write this one as, see, that is 38220 is greater than 196. So what happens? In the previous step we took A as 38220 and B is equal to 196. Then we'll start using the algorithm. By using first step here, by using Euclid's division lemma or Euclid's algorithm, so you have to write this in each step. Whenever using the algorithm, we have to write this. Now we have to write this greater number this side. So now this is equal to how much? 196. Now the smaller number into how much? 196 into 195 will be equal to this one plus remainder will be 0. So therefore here only one step and only once we apply, because directly we got the remainder as 0. So here remainder is equal to 0. So the dividend is equal to 190. How much? This one 195. So this is the answer. Only one step and it is very easy. So next we move on to the third problem. Third problem we are given 876 and 255. So we'll directly start. That is 867 is greater than 255. We have A as equal to 867 and B is equal to 255. 255. So next step is, so 867 will take, then the smaller number 255 into 3 plus how much, 102 will be the remainder. So 255 into 3 we get 765. 255 into 3 is equal to, this is just working, 765 we get, 765 plus 102 will become 867. Therefore what is the remainder? Remainder is not 0 here. So what happens here? We have to apply once again here, just by using Euclid's division algorithm. First step I have not written, just write this. So we get this one. So next step again, next step is, since this remainder is not 0, again by using Euclid's division lemma, so we have to take this one as the first dividend to 5. Then next step is divisor as how much, that is 102. 102 into how much, will take into 2 plus, so 102 into 2 will become how much, 204 will get, that is 204 plus 51 will be, that is 255. Therefore we have to write 51 here. Then how much we are getting? So here also remainder is not 0. Therefore finally again by using third time, using Euclid's division lemma, what happens? We have to take this one as the next dividend, that is 102 is equal to, next divisor will become 51 into how much, that is the quotient will be 2 plus, that is 51 into 2 will become what, 102, that is quotient will, sorry, remainder will be 0 here. This is quotient, this is dividend, this is divisor, and this is this is quotient, remainder, dividend, divisor, quotient and remainder. So remainder becomes 0. Therefore finally what is the answer is? Answer is, so the HCF, hence, or you can write HCF of 867 and 255 is how much? 51 is the answer. So this is the final step. The HCF of 867 and 255 is 51. So this completes the first problem. We move on to the second one. So in the second problem, given us, consider that any positive odd integer is of form 6q plus 1 or 6q plus 3 or 6q plus 5, where q is some integer. So here we'll start the problem. The positive odd integer will first consider, first step, consider, so consider positive, first we'll take any positive integer there. So the first consider a positive odd integer as equal to a. So next step is On dividing a by b, next step on dividing a by b, let q be the quotient and r be the remainder. So what happens, we have taken a positive odd integer as a. On dividing a by b, qv is the quotient and r is the remainder. So next step is, then next step, a is equal to bq plus r. So what happens, this one is quotient and this one is remainder. So finally we can write this one as 0 less than equal to r less than b, then this one as equation 1. So this is by Euclid's division lemma. So next step is, on substituting b is equal to 6, will take 6 in equation 1. On substituting equation b is equal to 6 in the equation, we will get a is equal to 6q plus r, where 0 greater than equal to r greater than, we will substitute here as 6. So this will be the equation 2. So next step is, so now possible, next step, possible values of r is equal to 0, 1, 2, 3, 4. Since here 6 is there, we have to stop till 5. Now first put r is equal to 0, or if r is equal to, or we can also write it as, if r is equal to 0, then equation 2 will be, so substitute r in the equation 2. So this is equation 2. Therefore we'll substitute, that is a is equal to 6q plus 0 will become, that is a is equal to 6q. Similarly go on substituting. Therefore 6q is divisible by 2, so it is even by 2, so 6q is even. So similarly substituting for all, again r is equal to 1, same thing, the equation 2. So what happens, will become a is equal to 6q plus 1. Similarly this one is not divisible by 2, so this is, so it is odd. Which one? This one, that is 6q plus 1 is odd. Finally we have to try for r is equal to 2, then r is equal to 3, then r is equal to 4, and r is equal to 5. So when r is equal to 2, we'll get, that is a is equal to 6q plus 2 even. Then when r is equal to 3, we'll get 6q plus 3, which is again odd, and r is equal to 4, we'll get 6q plus 4, which is even. Similarly r is equal to 5, we'll get a is equal to 6q plus 5, which is odd. So this is, you have to write stepwise, but I have written in the shortcut way, that's all. R is equal to 0, I have substitute and shown for even, or r is equal to 1, I have substitute and shown for the odd. Now see, all we are getting one alternatively even odd, even odd. So finally we have to write, since final step, since a is odd, so a cannot be, that is 6q plus 2 and 6q plus 4. Hence we have to write, hence any positive odd integer is of the form that is 6q plus 1, 6q plus 3 and 6q plus 5. So this cannot be in this form. So hence any positive odd integer is of the form 6q plus 1, 6q plus 3 and 6q plus 5. So hence we have to write, hence prove. So these are the steps to be followed for this question. Show that any positive integer is of the form. So we have to show this one. So this is the solution for the second problem. So we completed first and second problems in this exercise. If you have any doubt, comment me, subscribe my channel, share, like all the videos. Thank you.